Okay. So these type of questions are going to be part of the 5-mark questions in your first PU exams usually, right? In relations and functions, as you can see, define identity function, draw the graph of it, and write its domain and range. Such questions are very common, right? You must have heard of Signum function. You must have heard of greatest integer function, constant function, polynomial, modulus, and all these, right? Some of them we will see today, maybe 2 or 3 of them we'll see today. Okay, so let's pick up question number 7, define modulus function. Let's look into that, okay? Okay, folks, yeah. So define modulus function, draw the graph of it, and also write its domain and range, okay? Usually, even in competitive exams, modulus function, greatest integer functions are, favorite questions for teachers, okay? Fine. So let me first define modulus function for you. Anybody can tell me what is a modulus function from whatever you know?
F of x is equal to modulus x?
Yes.
Is the form?
Yes. So the function is f of x is equal to modulus of x. So this is how the function will look like. Okay.
X can either be positive or negative.
Yes. But the outcome will be always positive.
Positive.
Yes. So how do you define it? So definition goes like this. Good, Emmanuel. So how do you define? Yeah. So welcome, Avinash. I think we have quite a few students. After a few minutes, I will read out everybody's name. Okay. Just acknowledging you for joining the session. Okay.
Is it f from R to R is defined by f of x is equal to modulus x?
That's right.
For all x is an element of R?
Yeah. So for all x element of R, that's correct. But then to understand it clearly, right, we'll need to split this. See, this definition is insufficient. Okay. We have to give a detailed definition. So how do we do that? Let me show you here. So f of x is equal to minus of x when x is less than 0. This you'll be using it throughout, okay? You'll be using it in relations and functions. You'll be using it in, your differentiation. Extensively, you'll use it. You will also use it in your integration. All these places in next year, right? So this plays an important role. Okay, so this definition is very important to know. Okay, and even in this year, you're going to learn it in limits and derivatives also. All right, so modulus function is a very important function. So f of x is equal to minus x when x is less than 0, and it is equal to plus x when x is greater than or equal to 0. This is the complete definition. Okay, which means suppose if the value of x is minus 2, right? Then is that minus 2 less than 0 or greater than 0?
Less than 0.
Less than 0, which means I have to use this part of the definition. So what will happen is the answer will be minus of, what is my x value? Minus 2.
Minus 2.
So minus of minus 2 will become what?
Plus 2.
Plus 2. So the answer is positive. All right. Suppose if I take a positive number, let's say 5, then you will use this definition. If x is greater than 0, 5 is greater than 0. So your answer will be simply 5. Suppose my x is minus 10. Then I should use which definition? This one, right?
Yes, sir.
Then the answer will be minus of minus 10. So minus of minus 10 will become plus 10. Yes. So this is how you should define modulus function. Yes. Right. So we have defined modulus function now. So modulus function f of x is minus x whenever x is less than 0. When x is greater than 0, then it becomes simply x. So that's the way we define it. And it is always greater than 0. Your mod x is always greater than 0. Okay. Graph of it, that's important. Okay.
Is it a V shape from the positive y?
Yes. Absolutely, man. That's correct. Okay. So if anybody wants to note it down, you please note it down. We'll move to the next slide. Okay. Or next, I'll just scroll the space. I'll get to a new page. I think Madan has told he's not able to hear my voice. I think everybody is able to hear my voice.
Yes, sir.
Yes, sir.
Madan, can you hear me? Hear my voice now? If not, you check your audio. Okay. Now let's look at the graph of the modulus function. Okay, students. Okay. Now we're going to look at the graph of the modulus function. Fine. So if this represents, let's say, y-axis, and this represents the positive direction of x-axis. Okay. So when x is greater than 0, right? So x is greater than 0 is represented by these regions, like this region, to the right of y-axis. So that's going to represent x greater than 0. So when x is greater than 0, we know that f of x is equal to x, when x is greater than or equal to 0. So the function becomes simply y is equal to x, right? For example, let's say this is 0, this is 1, this is 2, this is 3, this is 4, 5, let's say. And let's say I mark this as 1, 2, 3, 4, etc. Okay. Now, if you see, when x is 1, what is your y? Y is also equal to x. F of x is nothing but y. So y is also x. So when x is 1, y is also 1. So this is the point. When x is 2, what is y?
2.
2. When x is 2.5, y is also 2.5.
2.3.
When x is 3, y is also 3. When x is 4, y is also
4.
So if I join all these points, so this is going to be the graph of the function for x greater than 0. But whenever x is less than 0, then f of x is equal to what? Minus x, when x is less than 0, right? This is the definition of mod x function, correct?
Yes.
So that means, let's say, let me mark these points as these are -1, -2, -3. Let's say this is -4, okay? Now, when x is -1, what you need to do? You should do minus of -1. What is minus of -1?
1.
Plus 1.
So it becomes here. When x is -2, then it will become minus of -2. That's +2. When x is -3, it becomes
Positive 3.
minus of -3 +3, like that, right? So for x less than 0, which represents the left side of the y-axis, right? So that's going to be given by f of x is equal to minus x, right? So if you see, as Emmanuel was mentioning, it's kind of a V-shaped graph. Is that clear? So that's going to be a graph of mod x function. Of course, if you want to know a little more about the angles, so this angle will be 45 degrees here. This angle will also be 45. Or from the positive x-axis, if you take, it will be 135, correct? Fine. So this will
So
be.
do we have to mention the angles and the graph?
Not necessary, not just for your understanding. I was just mentioning.
Sir, domain and range.
Yes, that's the next thing that we have to do. Okay. So y is equal to mod x graph. Are you clear, Mano?
Yes, sir.
Yes,
This is
sir.
the graph of y is equal to mod x. Now we go to the next part, right? The next part is basically we are going to do the domain and range of this function. I think we can do it right here. Okay, it's quite simple. So what do you understand from the word domain? Is nothing but set of all values that x can take. All right. Set of all values that x can take so that y exists. Or in other words, y does not vanish. Okay. So here, if you see whether y is equal to x, so in one part you have the definition as y is equal to x. In the other part, you have the definition as y is equal to minus x. Now, can you tell me any value of x that you substitute here will make y vanish? Vanish in the sense not exist. No value,
0?
right? No, 0 means y will also be 0, which is still a real number.
Okay, since it's a real number, it doesn't.
It exists. Rather than saying vanish, I should say, y should exist. All right.
Yes, sir.
Exists means 0 is also a number, okay? So that's fine. So x, any value you put, you will get a valid real number. Do you agree?
Yes, sir.
Yes,
Therefore,
Yes, sir.
all values, all real values are possible for x, be it this function or this function, correct?
yes,
Therefore, domain is nothing but domain of y is equal to mod x is real number, set of all real numbers. Are you clear?
yes, ma'am.
Any real number. So x belongs to all real numbers. That's all. Okay, that's the domain. Now next we will look at range. Okay,
So do we have to write domain as X as an element of R, or should we write it just as R? Real number.
it's fine. It's fine. Domain is R. Domain of y is equal to mod x is R. This should be fine.
Yes, sir.
Fine. You may also write this so that you understand. You understand that it is x. Always, when I talk about domain, it is a set of values that x can take. Clear? Just to emphasize that I have written it here. Okay.
Yes, sir.
Fine. Range. So what do you mean by range? Range is nothing but set of values that y can take. Set of all values that y can take. So that x exists. All right. Okay, here. So range of y is equal to mod x. So can you tell me what all values does, or in other words, if you want to write this you can write it as x belongs to minus infinity to plus infinity, open interval. Clear? This is another way of writing domain. Okay, anyways, we'll come back to range now. So set of all values that y can take so that x exists. So what is the range of y equal to mod x here? So what all values do you think, you have to just look at the graph here. What all values that your function is taking?
All the positive whole numbers of Y.
Positive real numbers, not whole numbers, right? So even if
Okay,
I have
real number.
0.5, I can have 0.5 there as well. If I have root 2, I have root 2 also. Are you with me?
Yes, sir.
Mod of root 2 is what? Root 2. Mod of minus root 2 is root 2. So it takes rational, irrational, all numbers, all real numbers are possible as long as they are positive, right? As long as they are greater than or equal to 0, right? So less than 0, it does not take, correct?
Yes, sir.
Exactly. So range is R plus, you can say. You can say it is R plus, or you can say positive real numbers. Or non-negative real numbers is a better word to use. Why do I say non-negative real numbers?
All
Because
the
when I say
Only
positive real
positive.
numbers, there is a tendency to take greater than 0. But 0 also should be included in the range. So you can say x belongs to zero closed interval, infinity open interval, 0 to infinity. Are you clear?
Yes.
Not x, but y.
So should we write R plus, or should we write 0, infinity?
0 comma infinity is say r plus when you write that also is used in many cases as non-negative real numbers, but then
So that
safer
will
side is
exclude
0 to infinity. Yeah,
Yes, sir.
but put a closed interval. Okay, and you can also write it in words, non-negative real numbers. Is this clear to you?
Yes, sir.
Yes, this is important. Okay. Mod X function is important throughout your first PU as well as second year also, and competitive exams also. Let's similarly look at another function now, which is also given as one of the questions in the PU board, right? Shall we get to the next question?
Yes, sir.
Ready? Okay. If you want to take down something, I will just wait for give a minute. Is there anything, any doubts? Anybody has any doubts? Anything that you need to understand? Anything that you need to want me to explain it again? Well, meanwhile, acknowledge all the students who are present today. Okay, welcome Emmanuel, Devraj, Shamita, Halesh, Jeril, Kelsey, Madan, Avinash, Parimala. Yes, okay.